Okay, in this example, we will construct both plots for the transfer function as shown here. So we will plot the magnitude plots and the phase plots. So in this example, the transfer function is given as shown here. Alright, h j omega equals to 200 j omega over j omega plus 2 times j omega plus 10. Okay, first step, what you need to do is to change j omega to s. Change from j omega to s for ease of calculation or ease of analysis, right? So here we have changed from j omega to s. Okay, next step is to do some calculation in order to rearrange or to represent the transfer function into the common or general representation. Okay, so here we have 200s over s plus 2 multiplied with s plus 10. So we have to rearrange the transfer function to make it look or make it into the standard form here. Okay, make it k s or 1 over s, 1 plus s over z, 1 plus s over p, and so on. So this is the standard form, and we have to change the transfer function to make it into the standard form. Alright, so because we want to use this table here, right? In order for us to use this table, we have to make it the transfer function to look in this form, in this factor. Alright, s 1 over s, 1 plus s over z, and 1 over 1 plus s over p. Alright, so here this is okay. 200 is the k. Okay, sorry. This case, this is the gain or k, right? That is okay. This is the 0 s, but here s plus 2 and s plus 10 is not in the form of simple pole. Okay, because simple pole looks like this: 1 plus s over p. Okay, 1 over 1 plus s over p. So this is not 1 over 1 s plus p, so we have to change. Alright, to do that, we just have to look at, for example, first we look at this 10 here. So we have to change from 10 to 1. Okay, so how to do that? We just divide this with 10, and since we divide this with 10, we also have to divide this with 10 as well. Alright, so now once we divide it with 10, we will have 1 plus s over 10. Okay, this is the result from dividing it with 10. Okay, we will have this, and of course don't forget that when you divide 200 with 10, you are left with 20. Okay, so this is okay now. Next is s plus 2. So this 2 here, we have to change it to 1. So we have to divide with 2 and divide with 2 as well. So what we have now is 1 plus s over 2, and 20 now is 10. So this is the standard form of k, standard form of the 0, standard form of the pole, a simple pole and simple pole as well. So now once we have rearranged the transfer function into the standard form, we can refer to the table and plot the factor one by one. We plot this factor, this factor, this factor, and this factor. So we have to plot 4 factors and then finally combine them. Alright. So here the first factor is 10. So 20 log 10 times k is 20 dB. Okay. This is 20 log 10 times k, log 10 times 10. K is 10. So the value is 20 dB. Okay, 20 dB. So this is 0 dB, this is 10, and this is 20. Alright, it depends on how you prepare the plot. Can be 0, 10, 20, and so on, depends on the value of the dB. Right. So that is the first plot for the first factor. Next is S, the 0. So 0 is straight line cross at 1 and the magnitude is 20 dB per decade. So this is the plot for the second factor, which is S. Cross at 1 Hertz. See here, this is 1 Hertz. Cross at 1 Hertz. And then another crossing at here. This is 10 Hertz at 20 dB. So we have here 20 dB. From here to here is 20 dB. From here to here is 1 decade. So this is the slope of 20 dB per decade. So you just plot a straight line from 0 to infinity. Okay. So this is interesting. This is the linear scale. Okay, but this is the from here to here, the x-axis is in log scale. Okay, so log scale is, for example, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 9 and 10. Okay, and then 10, 20, 30, 40, 50, 60 and so on, 100, 200, 300 until 1000, 1000, 2000, 3000, 4000 and so on. Okay, so this is the scale of log. And take note on the direction of the graph. Okay, for example, the gap between 1 and 2 is larger than the gap between 2 and 3. So the gap is getting smaller. Okay, the gap is getting smaller. So it is common that the student make mistake by using the different direction of the graph. Okay, so I've seen several times that the students assume that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is incorrect. Okay, so that is wrong. So take note on the direction of the piece of paper, the graph paper. Okay, so the distance, the gap should be the first is the largest, smaller. Okay, alright, so that is the second factor. The third factor is, let's look at the third factor, which is 1 plus s over 2. 1 over 1. Okay, take note here, this is, we have 1 over 1 plus s over 2. 1 over 1 plus s over 2 is this, which is straight line until P and then go down here. So what is P? P is here, S over P. So here we have S over P or 2, right? So from 0 and then once the line reach at 2 Hertz goes down as much as 20 dB per decade. So that is the third factor, which is this one. Finally, the fourth factor, 1 over 1 plus S over 10, okay, that is same thing, 0 dB. Plot the line, okay, don't forget to plot the line, and then at 10 Hertz it goes down negative 20 dB per decade, right? So that is the fourth factor. We have the first factor here, second factor here, third factor here, fourth factor here. So we plot all these 4 factors, and then finally you have to add them all together to get the final frequency response or word plot of the circuit. Okay, so how to combine that all together? So basically you have to look you have to look from left side of the graph. So starting from left, you have just a straight line here at 20 dB, straight line here 0 dB, and you have a straight line here at a certain slope, okay, 20 dB per decade. So what the combination of all this is actually this blue line here. So meaning that this straight line is shift up by 20 dB. Okay, this red line here is shift up by 20 dB because of this. Alright, so in other words, you have one plot at 20 dB, you have 2 plots at 0 dB, and you have another plot at positive 20 dB. So the total of these 4 plots or 4 lines at this frequency is this, right? Look at this here. This first factor is 20 dB, second factor is 0 dB, third factor is also 0 dB, and fourth factor is also at 0 dB. Okay, when we are looking at 1 Hertz. So 20 plus 0 plus 0 plus 0 is 20. So that's why we have this straight line here. We have this and this, plot a straight line here. Okay, but when we arrive at 2 Hertz, we have a straight line going down, right? So meaning that here we have 20 dB per decade, here we also have negative 20 dB per decade. So these two will cancel to give a straight line here. So that's why we have a straight line here, right? And then we reach 10 Hertz. At 10 Hertz, we have another line going down negative 20 dB per decade, right? So because of this straight line now begins to go down, right? So this straight line now begins to go down 20 dB per decade. Why? Because here from this point we have one line going up 20 dB per decade, but we also have this going down 20 dB per decade. So these two has cancelled each other, but we have another negative 20 dB per decade line. So that's why it is now the total is negative 20 dB per decade. This is the final amplitude or magnitude phase or magnitude plot. Alright, so next is the phase plot. So phase plot, we have to look all 4 factors one by one. So the first factor is the gain. So for gain, there is no plot, or the plot is basically at 0 degree. 0 degree. This is the first plot. Alright. And then the second plot is S, which is at 90 degree, which is this. Sorry, this is you have to remove this. Okay, this is no longer actually complete phase plot, because it's a combination of 20 dB and so on. So sorry for this slide, you have to disregard some of the value here. This is not alright, sorry. But what we can look is this. The first factor is K, but for K it is 0 degree. Okay, that is one. For K it is 0 degree. Okay, next is S, order 0. S is at 90 degree, so therefore we have 90 degree. That is the second factor. This is the second factor here. Second factor here. Alright. Next is 1 over 1 plus S over 2. That is this. 1 over 1 plus S over 2, which is P. So here we have negative 45 degree per decade. Okay, from P over 10 to 10P. Okay, P over 10 to 10P. Drop as much as 90 degree. So P is 2 here, right? P is 2. P is 2. This is 0.2. This is 20. Okay, this is 2. This is 20. This is 0.2. Alright, that case 0 degree. So this is 0.1. This is 0.2. Okay, and then down here, we go down here. This is 20 Hertz. Then go straight line. Okay, here, 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 straight line. Okay, because this is 0.2, this is 2, and this is 20, and this is 90 degree, right? So here, from here, go down here, and then straight line. Okay, now let's look at the final factor. This value here is 10. So this value here is 10. So this is 10. This is 100. 100. This is 1. 10 divided by 10 is 1. So 1, 10, 100. Okay, because of 10 here. So 1, 10, 100. Same thing. 1 and 100, straight line. Okay. Again, 1 and 100, 0, straight line. Before it was 0.2 to 20 Hertz, straight line. Then you have to combine all this together to get the final phase plot.